Good afternoon, sir.
Good afternoon.
Good afternoon, sir. So, sir, it is 4:01. Shall we get started, sir?
It is for you to decide.
Yes, sir.
You are the host.
Host. Thank you very much, sir. We'll get started, sir. Good afternoon, everyone. Very warm welcome to SAMVAAD. As you know, SAMVAAD is a monthly lecture series organized by IIT-Dharwad in coordination with Indian National Academy of Engineering, Bangalore chapter. Today, we have a very distinguished aviation engineer who is popularly known or considered as father of Indigenous fighter program in India. That is Dr. Kota Harinarayana. He was the program director and chief designer of India's light combat aircraft Tejas program. He was also formerly the vice chancellor of University of Hyderabad and a very distinguished guest professor in Department of Aerospace Engineering, IIT Bombay. Dr. Kota Harinarayana graduated from Banaras Hindu University in Mechanical Engineering and did his postgraduate studies in Aerospace Engineering Department of Indian Institute of Science, Bangalore. Later, he obtained his PhD from IIT Bombay. Dr. Kota Harinarayan started his career in 1967 at HAL and moved to DRDO headquarters in 1970, where he held various positions till 1982. He rejoined HAL in 1982 as a chief designer in Nasik division. He was deputed to DRDO in 1985 and assumed charge as director of ADE Bangalore. He was also appointed as a LCA program director in December 1985 and was elevated as a distinguished scientist by DRDO in the year 1995. As a program director and a chief designer of light combat aircraft, he successfully directed the project leading to flight testing and clearance for limited series production. Thanks to his efforts, India succeeded in developing a state-of-the-art high-technology fighter aircraft of world class. Dr. Kota Harinarayan is a recipient of several awards and honors. He is a fellow of Aeronautical Society of India and its former president. He is a fellow of National Academy of Sciences and Indian National Academy of Engineering. He has received the Distinguished Alumnus Award from Indian Institute of Science, Bangalore, and from IIT Bombay. For his leadership, he received the DRDO Technology Leadership Award for the year 2001. Indian National Academy of Engineering and DRDO have conferred upon him the Lifetime Achievement Award in the year 2006 and 2008, respectively. Recognizing his immense efforts, he was honored with Padma Shri by Government of India in the year 2002. Please join me in welcoming Dr. Kota Harinarayana for SAMVAAD. Sir, it's our great pleasure to have you on SAMVAAD. And before I hand over to Professor Kota Harinarayana, I have a small request to the audience. Please type your questions in the Q&A box in the bottom right side of the screen, and we will read it out to Professor Kota Harinarayana. Sir, thank you once again for accepting our invitation, and over to you, sir.
Thank you. Thank you. I'm seeing my colleague, P.S. Subramanian, is also on the line. You can see that. Okay, good. Shall I start now? It's a pleasure to be here.
Yes.
And grateful to IIT Dharwad for inviting me. And I look forward to good interactions with all of you. Now we are talking a lot about Atmanirbharta, how India can become self-reliant. And in my opinion, a country will be self-reliant truly only when it is able to export. So to reach that level, we need to put a lot of effort, but I am sure we will be able to do that. I'm happy now. Just now I saw Professor Seshu also I joined. Good. Now I think time to start now. Let me see. Hello, Professor Seshu.
Good afternoon. I just closed the other meeting and I joined.
Yeah, I can understand the problems of a director.
Thank you so much for agreeing to give a talk. It is so nice to have you.
I'm seeing that Sunil Sherlekar also is there.
Yes. So in fact, it is live streamed on the YouTube channel of IIT.
Yeah,
so many people will be watching it in that.
Yeah, I thought so. Okay, so let me see. Yeah. We have done 2 trials that how to open the what you call PPTs. I hope at the actual time comes, I'm able to open.
It has come.
Yes.
Slowly it is coming. Yeah.
Yes.
Let me hope it is coming.
Where is your presentation?
I will just see whether I have.
Right.
Has it come now?
It
Yes.
is coming. You just go to
Let me go to the full
screen.
screen.
Right.
Is it okay?
It is fine. Bottom you will find this hide. If you press on hide, that line will go.
Which one?
There is
Hide if you do.
hide if you just press on that.
Yeah, so it has gone now.
You are
Okay.
ready
Good
to-
stuff. So I hope
Please.
my topic, Atmanirbhar Bharat in aviation, that is the topic. Okay.
Right.
So I'm talking here from the light combat aircraft to the regional transport aircraft, a 90-seater passenger aircraft. We have been working for quite some time. I'm looking forward to that project also coming through soon. So let me see what we have done at LCA, what all the things that happened beyond the light combat aircraft, and what are the now challenges ahead, and what are our aspirations, and what are the projects that are coming up, and how that will help the young people of the today and tomorrow in taking up challenges and making the country Atmanirbhar. Now, let me start with the important statement that technology is the strength and creator of wealth. Today, I don't think anybody will have any doubt on that. But the question is, how do we achieve the technological strength, and what is the fastest way to reach our goal? We have been behind because of various reasons. So what is the fastest way? The survey of technological development in the world shows aviation has been one of the most significant technological influences of our time. World over has been the prime engine for development technology, leading to wealth generation. It also provides military might, ensuring not only national security, but if you're strong in aerospace, you also have a dominant voice in international relations. So you have strength, you have wealth, and you have a dominant voice in international relations. There is also a direct relation between wealth of a nation, its defense strength, and its leadership in aerospace technologies. Today, countries like USA, France, UK are good examples where aerospace leadership resulted in a high quality of life. Let us take the case of USA. 80% of its exports are aerospace, and 70% of passenger aircraft operated world over are produced in the USA. It imports almost everything, but it exports the aerospace products. So all that import doesn't mean anything because it is able to export aerospace products, and that is where its dominant position has been ensured. So I think today we are exporting textiles and all those kind of things. I hope we'll reach a stage where we will export aerospace products, aircraft, and we don't mind importing some textiles. I think that is the stage where we should come. Now let us look at military aviation. In aviation, largest investments are made on military aircraft. They are linked to national security and air superiority. Military aircraft have the most demanding and more diverse performance requirements. Very, very demanding because a few seconds of advantage you have against adversary that decides your success or failure. We have an advantage of few seconds, let us say 3 to 5 seconds, you win. So that advantage you get only with the best of aircraft, which comes from best of the technologies. So the best technologies, often the best science emerges from development of military aircraft, more especially the fighter aircraft. That is what happens. It was during the Second World War, fighter aircraft bombers were used extensively. Okay, before that, aircraft were there, but not used as fighters. In the post-Second World War, the role of air power increased by leaps and bounds. And now it is acknowledged by all strategic thinker plan, a war is not winnable unless one has air superiority. Indeed, no nation enjoys air superiority ever lost a war by the force of arms. Before I go further, let us have a look at this. After Second World War, there were generations of fighters that came, each with a better technology, better weapons, better system. The first one is for a decade soon after the Second World War, They are the first jet aircraft. Earlier, they were not. They were all piston engine and all that. They were all subsonic, below the speed of sound. They had guns, bombs, and rockets. That was the first generation. The second generation, aircraft became supersonic. They started flying above the speed of sound. First generation radars came, and first generation missiles came. Okay, these are the things which again came after about the second generation came. Quickly, there was a third generation, and they are all multi-role. Earlier, whatever there, they were used either air to ground for attacking, for dropping bombs, or for air superiority to fighting against another aircraft. Those are the kind of specific roles that were there. But first, then third generation multi-roles came. They can do air to ground, air to air, air to ship, all those kind of things. They are all supersonic fighters. They have advanced radars, advanced missiles. Okay. In India, in the first generation type of aircraft were NAT aircraft and all. In the second generation, we had the MiG-21 aircraft, Russian origin. Both were licensed manufactured. Third generation, very prominent aircraft is the Mirage 2000. I've shown that one here. This is a French aircraft. We bought those aircraft. Okay, these are the kind of things. And the fourth generation, they are the advanced avionics, guided weapons, high agility and speed, very next generation radars, next generation missiles, some amount of treatment for low observability, some amount of treatment. These are the kind of which are fourth generation. The light combat aircraft, which was designed in India, designed, developed and all, that belonged to this category. The fifth generation, what today US has a fifth generation fighter, there, that F-22, F-35 and all, they are designed with stealth as the optimization parameter, and internal payload, information fusion, net-centric warfare, sustainable, deployable, total air dominance is the purpose. They are the kind of aircraft which are there. So how do we, when we took that LCA, light combat aircraft, let us see where the situation is. India in 1958-55, it started developing an aircraft called HF-24 Marut. Aircraft looks beautiful. It was designed by a team of Germans headed by Professor Kurt Tang. He was a very successful fighter designer of Germany. And so Indian government invited him. He went from Germany to Argentina. From Argentina, he along with 18 of his German designers, they came to India. And this aircraft was flew 1961. Unfortunately, because they didn't have an adequate engine, aircraft never became supersonic. In fact, it remained a subsonic aircraft. And they wanted to make it as a aircraft supersonic with advanced radar, missile radar. None of them could happen. It remained essentially a first generation fighter with guns, rocket pods. Okay, and that was afterwards, the next 30 years, nothing has happened in the country. No progress has taken place. Well, the rest of the world moved fast. They made second generation, third generation, and then they came to fourth generation aircraft. But we remained there. So the challenge for LCA was to, from the first generation HF-24, which flew 1961, the fourth plus generation 2001, the LCA has flown, and some of the core technologies that are required are embedded in this aircraft. Even in this aircraft also, Air Force said you have to put it on an aircraft, new aircraft, test it, flow it, then we'll be able to support you further and full-scale development. So for crucial technologies, fly-by-wire controls and controllers, computer control mechanical system, advanced digital avionics, and extensive composite materials, we have developed all of them. All of them together were put into the aircraft, and that is the aircraft which flew in 2001, almost now 20 years are over. This is what happened. When aircraft flew, not only the aircraft flew, but all the technologies that were developed, where I think the academic institution, the R&D laboratories, and lots of small and medium-scale industries participated. This is the first program in the country where so much of participation came from academia, R&D, and small and medium scale industries. So this is the aircraft of 21st century, air support for India, very lethal, very heavy, an array of precision weapons, both air to air, air to surface, air to ground and all, very accurate nav attack system, very smallest fighter in the world, and reduced signatures, highly integrated avionics. It is a true multi-role, all-weather, day and night fighter. Online health monitoring. So it has half the maintenance man hours per flight hours and twice the mean time between failure. And the aircraft has been in operation now in Indian Air Force for almost 5 years. And it has proved itself extremely well. Its track record is very good. Some of the best technologies were introduced, developed in the country and introduced. And except the engine, which we are still importing, all other things have been developed in the country. It is an unstable aircraft that makes the aircraft agile and highly maneuverable. It is this agility that gives this aircraft an edge over adversaries' aircraft. Small size, very high instability level, okay, very advanced controllers, all digital cockpit, all these things put together, very lightweight car, makes it a formidable weapon in the sky. The aircraft proved itself highly reliable. In fact, all these years of more than 20 years of flying, we never had a serious accident or incident. Maybe this is the only aircraft program in the world which has this safety record. The JAS-13 Gripen of Sweden, other aircraft, the Russian aircraft, the Chinese aircraft, the American, all of them had serious accidents, fatal accidents, serious accidents. But this is one aircraft which has maintained its track record of high safety. And the design, what has been done here, the technology, the process we followed in testing, manufacturing, and final output that is coming out has proved itself to be an extremely robust system with a very high reliability and very high safety. And a lot of maintenance features have been built in, and that is the reason why it makes it and we are continuing to improve its maintainability. The LCA Mark 1A will have further improvements in maintainable. Mark 2 will have further improvement. There's a continuous work that is going on to make this aircraft highly maintainable. It is already very, very reliable, and availability is extremely high. Recently, the Indian Air Force at Sulu has flown 14 aircraft in one go to demonstrate that at any time it has more than 75% of availability. So that is a very good credit to this aircraft program. One of the key features of this aircraft is advanced carbon composites. 90% of the surface area is carbon composite, about 10% in the rear is metal, and by weight it is about 45%. Possibly among the highest percentage of composites in the world today. Only when Boeing 787 flew, it had a higher percent, above 50%. Okay, so that is the level of composites that have been used. When we started the program, we had zero knowledge of composites. And our work together between academia, R&D, and industry, when we work together, we are able to go from 0 to 90% surface area of composites and 45+% by weight. Okay, it's a program that really given a jump start to us in this technology. The other technology which makes this aircraft what it is the integrated flight control system. And now almost all the parts that are here have been indigenously developed. The controllers are from day one are indigenous. And in fact, controllers are prohibited items from USA. A national team sat together and they developed this one. And the controllers are considered one of the finest outputs of this aircraft program and liked by all the pilots. In fact, it makes the pilot vehicle as an integrated system. And that makes it really a wonderful air superiority fighter. It's a all digital cockpit. And as a result, it makes this as a a truly good digital weapon system and weapon management system, and that gives that edge to the pilot in this cockpit compared to adversaries whom he has to meet, and that makes it really, and it has weapons from indigenous weapons, Western weapons, Russian weapons. So it has been designed such that all these weapons can be carried and fired without any problem of interface. And when a new weapon comes, you are able to interface them without any mechanical adapters and all that kind of a thing. Possibly the only fighter in the whole world who can carry and release an array of such weapons anywhere in the world. Okay, I think that is what all the distilled experience of Indian Air Force has been brought into this aircraft, and it has proved itself over a period, many campaigns, as an excellent fighter, and it has excelled compared to all other aircraft that are there in Indian Air Force. The avionics is the one which makes this aircraft a weapon system, and this is the one which interfaces all the general systems, flight control systems, cockpit, pilot, everything put together. So this is a crucial fellow, and this is the one which has been, most of the things are indigenous and gives the edge to this aircraft. Interestingly, a lot of things for the first time in the country we have done indigenously for the fun. Otherwise, most of these equipments were being imported, whether we have done our own aircraft, license or anything, even in HR-24, Kiran, all these aircraft were imported. But here, for example, the environmental control system, the crucial, cold air unit, heat exchangers, all of them have been developed indigenously, developed by our own industry in partnership with labs and academic support. And that's what has happened. Hydraulic system, the complete hydraulic system, which consists of landing gear, wheels, brakes, the secondary system, the gearbox, all of them have been developed. The hydraulic pumps are in a stage of development. I hope in next few years it will be available. But a lot of work is going on. The carbon brakes, first time the carbon brakes have been made out of carbon material. Our friends from ASL in Hyderabad, they developed this one. It is a successor to the carbon technology they developed for their missile program. Okay, and the LCA project took it further to the next level. That's what we have done. This is the secondary power system, where a jet fuel starter, the aircraft gearbox, the P2S shaft, all of them have been done indigenously. And the heat exchangers, fuel cooler, oil cooler, all of them, 1 and 2, all of them have been done in this very, very well. And over the last 20 years of flying, they proved themselves well and proved their integrity, performance in all ways. Okay, and that is something credit should go to our teams who have worked on this one. As I mentioned, the brake is a brake management system. It's not a conventional brake. The wheels, the brakes, the brake sectors, all of them have been done indigenously. The wheels and brakes have been developed by our friends in Lucknow division of HL, and the brake sectors have been developed by ASL, Advanced System Limited at Hyderabad, our missile complex, and all other components, transducers, pedal, everything has been developed. The control units, all of them developed. And they all now proved themselves quite well, and they are doing very well now in the aircraft. This is, in short, the kind of technologies we have developed, the organizations who have participated. Thus, parallelly, while we are going ahead with the development of LCA for the Air Force, the Indian Navy requested that why not we requested to take up the development of LCA Navy. And there are not many countries who have developed a naval aircraft. While there are many countries might have developed the fighter for the Air Force, we may be among the 5 countries who have done this kind of job. A lot of effort has gone in, a lot of innovative technologies have gone in. And today, LCA Navy has flown, and it has flown from our own aircraft carrier. Okay, the very takeoff technology, the landing technology, each one was a challenge. But I'm happy to tell the team at LCA team, they have succeeded, and today the aircraft has proved itself. The Indian Air Force now looking for a 2-engine aircraft. They feel a single-engine fighter may not be adequate for their strategic interest. So that work is now being taken up by ADA now. So you could see that the takeoff and landing flight trials have been very well done, and results have been pretty good, very satisfactory. I just thought I will show this. It's quite often all my colleagues, my friend Subramaniam, many others have been showing that it is truly a national aircraft, a national program. You could see that very large number of institutions in the world, and this created an ecosystem for the aviation in India. This project has led to a creation of an ecosystem where people have developed the enabling technologies, the core technologies, the equipment that are required, the test facilities that are required. And now there are major industries and private sector who are supporting HAL in manufacture of the wings at Coimbatore, front fuselage, the center fuselage, the rear fuselage, all other things are being done. And that is where the strength of this program is. And this strength is what we do believe it will be helping us in getting into variants of LCA, new generation fighters, and transport aircraft, and many other things, and unmanned vehicles. What have you done? With a single mission called LCA, lots of things, new ideas have come out, new innovations have taken place. Lot of skill and facilities have been created. Some of the facilities we have created are world-class and first of the kind in the country. And these are all done in the country. And a lot of skill sets have been done both in hardware and software. The technologies, not only core technologies, what I talked about, but also the what you call enabling technologies. We are talking about CAD technologies, CAM technologies, computer-aided engineering technologies, modeling and simulation technologies, reliability engineering, then testing technologies and quality control, quality assurance technology, software. Development of safety critical software, mission critical software, all of them. The first time in the country we developed such safety critical software to this program. And lots of national teams were 3 national teams we formed to solve critical things like a wing. We had to make a national wing team, national controller team, a national flight test team have formed. And this is the project where hundreds of the faculty and students from universities, IITs and other universities, R&D labs, industry, they learn to work together, learn to improve their productivity and come to a level where the productivity has the first-class, world-class fighter they could develop. And this lesson they have learned, the culture that they have created is helping the country in the years to come out with really complex world-class products. That's what I think. The next project that Aeronautical Development Agency is busy is called LCA Air Force Mark II. This is a much bigger aircraft. You will see it has canards, and it has almost twice the payload it can carry. LCA was carrying 3,500. This fellow will carry 6,500. The fuel capacity has increased, payload has increased, slightly increased in size, and it's a more powerful engine. So this is what it is. And this now advanced, detailed design work is in progress. We are looking forward to this aircraft getting into sky in the next couple of years. So you can see that it has a new systems, large number of new radar, new IRST, lots of things are happening on this one. It would be an aircraft which the Indian Air Force plans to use in a big way. I hope you can see that the kind of weapon carrying capability it has is really remarkably good. Now what happened now, these are the aircraft which were in Indian Air Force until LCA entered into service. So short and medium range, MiG-21, MiG-23, MiG-27, they are all being now replaced by the light combat aircraft. Already 2 squadrons have been formed. The LCA Mark II, which is a much bigger aircraft, the Indian Air Force is planning to replace the MiG-29, Jaguar and Mirage 2000. And possibly the Su-30 will be replaced by a 5th generation fighter. Except the trainers, everything else was imported. And we are looking forward to this import being replaced with Indigenous. This is the advanced medium range combat aircraft, very, very advanced technologies, stealth technologies, all avionics, every them highly survivable, and future generation of weapons. These are the things which are coming in. You could see that it has a super cruise, diverterless intake, low infrared signature, advanced integrator controls. That is what it is. Not so integrated in case of LCA, but it has that. And flight dynamics, internal weapons it will carry. It's a challenge to carry weapons internally. It control of high asymmetry, reconfigurable control system, advanced airframe. It can carry weapons internally. Stealth airframe. LCA is not a stealth airframe. It has some stealth features, but not stealth airframe. Very advanced radome. And advanced avionics, situational awareness, decision support system, and flash and body control antennas, advanced communication net-centric warfare. Materials for stealth. This is something what is important for this class of aircraft. And advanced manufacturing. They are planning to use jigless manufacturing, superplastic for cooling. That is what they are doing. So the outcome of LCA Mark 1, 2 squadrons, and they are going to make 4 more squadrons. Indian Air Force placed an order on HAL for 123 aircraft. Well, Mark 2, Indian Air Force is planning 10 squadrons. AMCA Mark 1 up to 2 squadrons, and AMCA Mark 2 up to another 5 squadrons. The complete self-sufficiency combat aircraft by 2032. So you could see that the LCA and its successors are enabling the Indian Air Force to become totally self-reliant, self-sufficient in combat aircraft. And combat aircraft are the most complex aircraft developed anywhere in the world. So that is one important thing that has come out from the LCA program and towards the Atmanirbhar Bharat. Now let us look at the unmanned air vehicles, because today slowly from a manned fighter, the air forces, many air forces in the world, including Indian Air Force, are looking at using unmanned air vehicles for combat roles. Okay, this is important, knowing the situation, and it gives tremendous benefit to the Air Force. If they have a aircraft can be used for combat, both air to air, air to ground, and all these roles. The combat have some 2 kinds of philosophies. What is called medium altitude long endurance vehicles. They fly for 30 hours and all. That's what I showed on the left side. And they can be weaponized. They can carry some. They are all subsonic aircraft, low cost, minimal stealth, opportunistic targets against minimal air defense, not very heavy defense, but it can be used or being used there. Okay. A second is the stealthy flying wing, high subsonic, fairly expensive because of the nature of the aircraft. By ab initio, low observables, very low observables, strategic target against organized enemy. These are the 2 types of what you call combat aircrafts that are now being developed everywhere in the world, so also in India. So these are the male unmanned air vehicles which are operational. Famous one is the RQ-1 Predator and MQ-9 Reaper. Both of them have been used. Both are General Atomics in USA. This is the company which makes them one. You can see the differences between the 2. One is a 1-ton class of aircraft, whereas another is almost 5-ton class. One could carry about 200 kilograms, another could almost 2 tons of payload. Speeds are high, ranges are high, service ceiling is high. Okay, and still a single engine aircraft, still smaller than a fighter, manned fighter. So these are the things which are there. It's more like, as I said, medium altitude long endurance aircraft used as modified to that. So the stealthy UCAVs, okay, these are the ones who are they are used for precision strike support, primary missions, seed. In the seed role, they identify hostile radars, geolocate radars, decisive, suppress radars, bombs and weapons. They are used for the strike to identify targets, geolocate, strike with bombs and weapons. They are also used for damage assessment. Once a fighter, what called 4 or 6 fighters go and bomb an area, these aircrafts are used to do what you call damage assessment. Now, the next generation with the stealthy flying wings, all over the world, this development work is going on. None of them are yet operational, but a lot of work is going on all over the world, including in India. ADA is working in that. The well-known names are here. They're X-47B, Phantom Ray, Neuron. These are the things. All are experimental aircraft. None of them are operational. But likely next 5 to 10 years, they may become operational. So you are some of the further ones which are there, including Russia. UK is doing that. China is doing that. So we are also doing in this area. So there are aircraft like fighter aircraft like F-16. They have been converted into unmanned fighters. So, for example, F-16 has been converted into an unmanned fighter. And they have their advantage there because some of the aircrafts are old. You can't use them for a manned fighter. But the airframes with their equipment and all after modification, you can certainly use them as unmanned vehicles. Or it can be used what they call as optionally piloted. Pilot can go inside and fly, or pilot can be outside and fly the aircraft. The Indian-UK scenario, many years back, more than a decade back, Aeronautical Development Establishment, establishment, developed a flying wing strike aircraft. It can fly for 14 to 16 hours. They tried with very light weapons and all that, and they converted the manned one to unmanned, and successfully they have done that. The Indigenous UCA for strike role. This is what ADA was doing. Now ADA had this responsibility. It's a flying arrow wing configuration. It's powered by our own Kaveri dry engine, internal weapon bay, reuse improvements from LCA flight control system, improvements from UAV avionics system, re-engineering of mission sensors and data links, improvement of UAV GCS for mission comfort, simulator thrust on indigenization and participation in Indian industry. Because this is a program where outside the country the support will not be there, which is a blessing in disguise because that will help us to develop everything within the country. And that is what is going on now. So the stealth is a concurrent design driver here. You have to have performance consistent with what you call stealth features. What are the stealth we are talking about? One is radar cross-section, another is IR cross-section, third is acoustics, fourth is visual. You have to, from a longer range, RCS becomes important. When you come a little closer, IR, infrared becomes important. Then further closer, acoustics, noise becomes important. And further closer, visual. All the four elements have to be tackled. And that would mean you are doing a system where RCS and IR one side, aerodynamic, propulsion, airframe, avionics control, all of them are simultaneous, a multidisciplinary optimization is the challenge. And that is what is going on in design of this aircraft. Okay, this is the real challenge. Okay, and this aircraft has to operate along with other manned aircraft and other unmanned air vehicles, manned aircraft like LCA, and AWACS aircraft, which will fly above the thing, spy satellites, communication satellites. It is a net-centric system. And in that system, in a cooperative mode with the friendly forces, it has to work together so that together they are 10 times more effective than alone being effective. And that is the basic requirement. So from ab initio stage, these aircraft are being developed as net-centric warfare capability into each one of these fighters. This is broadly the kind of things that are happening in the area of combat aircraft, both manned and unmanned. And the LCA program has gave us tremendous confidence, not only people who are developing, but also people who are operating this aircraft, the Indian Air Force, the manufacturing people, hundreds and hundreds of what you call industries who are manufacturing components, equipment, assembling, supporting HAL, supporting the R&D groups, and doing this one. So what then the point that comes up is, what about civil aviation? We have a large number of, quite a few types of aircrafts we are using. Some are made in India, but we are not made in them. There is no single operational civil aircraft today in the country. We are the only big country. If you look at Brazil, Russia, India, and China, we are the only country who does not have any what you call civil aircraft of our own design, which are flying operationally and flying for commercial airlines. So this is the challenge which we need to see. So some 2 decades back, National Aerospace Laboratories initiated some work in that, and we are moving forward. These are the kind of aircraft normally civil aircraft which are in operation. One is the light aircraft, what you call utility aircraft. They are normally between 2 to 9 passenger capacity. Second is called commuter aircraft, about up to 19-seater aircraft you can do. They have a range of about 500 to 600 kilometers. And then the regional aircraft got 50 to 70, and now they are going to 90 also. I should have written as 50 to 90. Okay. About 1,500 kilometers of range. They are all turboprops, propeller. All these are all turboprop aircraft only. Okay. Then the narrow body aircraft, you are all flying in Boeing 737, Airbus A320, their variants and all of them. They are almost 800 kilometers per hour, 8 to 900 kilometers per hour, turbofan aircraft. They can carry 150 to 200 passenger capacity. Their fuel capacity can be 20,000 of that order, whereas the earlier ones are much smaller fuel capacity. For example, the regional aircraft is about 5,000, whereas the commuter aircraft is about 1,500 and all that. About 100 kilograms will be for light aircraft and all. The wide body aircraft, you have seen A320, the typical aircraft, 747 other, they carry something like 250,000 at that order of fuel capacity. Very, very long distance, very big aircraft, 800 passengers. That is the kind of thing which are now in there. These regional aircrafts are of two types. One is the turbofan and turbojet. Earlier, when the market was North America primarily, they were all turbofans. But Indian environment, quite a few of the Asian countries and all, they're finding turboprop is more fuel efficient. And today the fuel costs are up to almost a barrel costs $100. So fuel efficiency is important. Also environmental impact. A turboprop consumes less fuel, so it becomes more environmental friendly. So for these reasons, we thought we should now look into this class of aircraft. The Hansa is a two-seater aircraft developed by National Aerospace Laboratory. Initially, they developed almost 15 years back Hansa 3, and over a period of time, technology has varied. So they now rolled out Hansa NG last year, and this aircraft is now in the final stage of certification. And this aircraft will be made by the private industry. And already I understand from Director NL, more than 70 aircraft orders are there. And aircraft people are waiting for this aircraft to be certified and produced in the numbers. So this will be, when it enters, this may be the first aircraft which will go in numbers. Though Mark 3 went for a 15, 16 aircraft, this will go in numbers. And that's what we are looking forward to. The other aircraft which has been developed by public-private partnership, NAL on one side, Mahindra Aerospace, other side, they developed a 5-seater aircraft. In fact, they made a prototype. They flew the aircraft. But today regulations in India ask for 2 pilots to fly this aircraft because it is above 1,500 kilometers, 1,500 kilograms. And if you fly, for 3 passengers, if you put 2 pilots, it becomes extremely uneconomical. As a result, they have not gone beyond initial flight testing. But if the regulations change, I do believe it should change. And we should be able to bring it back into operations. This is an aircraft which was made under license for Indian Air Force and other allied services by HAL at its Kanpur division. It is unpressurized, not suitable for high altitude operation. Today, the cost of acquisition operation is high, very high import content. But with the modernization and enhanced indigenization, it should be possible to reduce the cost of operation. And then it should be able to meet those sectors where the traffic is low. And but it can only fly at altitudes below 8,000 feet. So that is the limitation. But aircraft is available. The Indian National Aerospace Laboratory took up the development of a 14-seater pressurized commuter aircraft. It flew a few years back, but then there were issues and problems and all. So recently, the government of India given a clearance for making a 19-seater pressurized new technology aircraft. Various alternate things were considered. Finally, the Mark 2 will be a tractor. That means the engine is on the wing, whereas the Mark 1 was having the engine on the rear in the fuselage. So this is the troop transport, VIB, and cashback, a lot of applications. Aircraft in advanced stage of design, and manufacturing. So we are looking forward to the aircraft coming out end of 22-23, and this will be able to fulfill the requirement of airfields which are at higher altitude, where a Dornier cannot do, and this has that advantage. And we do believe that will meet, especially tourism, high altitude operation, and many such things. It will be able to meet. Indian Air Force has consistently supported this program. Initial orders have been placed by them. So we're looking forward to this aircraft flying in another 2 years. It's an old aircraft, HAL Avro. It was produced almost 25 years back under license from BAE Systems, in those days, Avro company. And it can go from 40 to 58 passenger aircraft. It's a pressurized aircraft, fly about 400 kilometers. It has very old generation engine. Most of the systems are all old generation. Recently, a study was undertaken to see whether we can upgrade this engine, avionics, and the systems so that it can meet that segment where 40 to 50 passenger capacity is required. It has excellent field performance, very small takeoff and landing. It has a very big wing and a very efficient about high lift systems. Aerodynamics is fairly good. So that study is going on, and HL has already modified one of the aircraft with new avionics. They are in the process of modifying the aircraft with the new engine. And we do believe, we have done study, we do believe that in the UDAN program, which is a new program which regional connectivity is given importance, subsidy is given to airlines whereby passenger need not have to pay more than 2,500. We do believe there is a segment of the market where this can fit in. So we do look forward to this getting revamped, revived, and get going with the thing. These are the things which can meet a partial requirement. But with the UDAN program and other things, India has become the biggest market for regional turboprop aircraft. And the existing aircraft like ATR 72, ATR Q400, they're quite expensive. Costly to acquire, expensive to operate. They need extensive maintenance. They can operate only from well-equipped airfields, and high fuel consumption, high emission levels. Some of the technologies like engine technologies, 3 to 3.5 decades old, very old ones. And so India being the largest market now, a lot of discussions were held with the operators. There is unanimity in the operators. They said they certainly need a new generation aircraft where fuel consumption less by about 20% and reduction ownership cost by 20-25%, speed around 500 to 550, little more cabin space, but even this is adequate. A lot of reduction maintenance, improved environmental performance. If you fly by ATR 72, when the aircraft lands and they don't switch on the ECS system because they don't have a jet fuel, APU, so it becomes very hot. And ability to land in ill-equipped airfields with the aircraft. And they say the traffic is growing, so 70-seater is not good enough, make a 90-seater. That's what they've been talking about. And these are the kind of inputs. And all the airlines, they were all very supportive of this one. So we thought that we'll have a aircraft which has a 25% reduction in the operating acquisition, fuel consumption, and 50% reduction in maintenance, very good takeoff landing performance, all-weather operations, emissions lower by 70%. Then we will meet the international desire to reduce the emission there and enhance its safety. A lot of studies have been done now. For more than a decade, we have been working on this. But still, we are waiting for a go-ahead because it's an expense more than $1 billion. It costs, okay? Lot of studies, lot of things are going on. Lot of new technologies are required. Quite a few of these technologies we are borrowing from light combat aircraft. Some like fly-by-wire system, composite material, we have been borrowing from that. And a lot of avionics, avionics systems, maintenance concepts, we're taking for LCA Mark II and all that kind of thing. But more electric aircraft system, coating technologies, these are the things. The new engine is required, and we are looking forward to that engine will not be available in India. We still have to do a lot of work in that one. A very advanced laminar supercritical wing is what we are looking forward to. A lot of new technologies, fair amount of technology work has been done Once the go-ahead is given, this will get the boost that is required. So you could see that in this aircraft, our market is, we are the largest market in the world. We have a window of opportunity for development of a new generation leased and aircraft, a variant that could meet the requirements of Indian Armed Forces. Okay, while we are now moving forward in terms of fighter aircraft, okay, and technologies are available, things are moving forward, we need to make a decisive step forward in the area of what you call transport aircraft. While small, 2-seater, 5-seater, 19-seater, we have money required is less and sanction has been, approvals have been given, but this bigger aircraft cost more than $1 billion. We are awaiting the clearance. A lot of work has been done by the groups at NIL and with support from others, but we need to get a go-ahead so that we'll move forward. The September 2018 says India is the third largest. It was talking of 2018, but India is the third largest domestic civil aviation market in the world. And in the next couple of years, if there would have been no COVID, we would have reached the third largest international traffic also, domestic plus international traffic. But everybody feels by 2024, we will become the third largest market in the world, okay, next to USA and China. That means for such a huge market, such a great opportunity, we must now all work together to see it happens. So tremendous opportunities in both civil, military and civil aviation. India should try to be a leader in aviation domain in a decade's time. Essential to enhance investment, realize the potential opportunity. And once a country becomes Atmanirbhar in aviation, it has been shown elsewhere in the world that you become technological superpower. And that is what is required for a big country like India. Thank you very much.
Yes. Thank you very much, sir, for a very nice presentation. There are a few questions which I will read it out to you, sir.
Shall I switch off take off the slides, or you want me to keep the slides?
It's up to you, sir. It may not be essential, sir.
Not essential, huh?
Yes, sir.
Shall I then switch off?
Sure, sir.
So that, that we can see.
You can stop presentation.
That's what I'm thinking.
Stop presenting.
Stop presenting, I will do.
Correct.
Is that okay now?
Yes, sir. Yes.
Okay. Thank you.
Thank you, sir. Sir, the first question is, dear sir, is there a systematic plan to share the best practices with other defense projects?
It's a good question. Professor Sesu was there in both sides. There is now, we are making, we have done some studies. We are putting together a lot of best practices that we have done in LCA and all. We are also sharing with our IIM Bangalore friends. But if you are asking whether there is a book or anything, I think that book is a requirement. I think we need to put it together. Then I think it will be a very useful thing for the succeeding generations for that. We'll certainly work on that. Okay.
Sure. Okay. Thank you, sir. Next question, sir. Have there been or will there be any spin-offs of the technologies developed to Indian industries?
I've already shown there are first is next generation fighters. We have already gone ahead. Unmanned air vehicles, seriously going at. In fact, today, the technologies that have been developed here have gone into unmanned vehicles in a big way. And quite a few of the startups which have come up, for example, there's a startup at the Indian Institute of Science who are making the drones for agricultural operations. It's a drone, totally indigenously developed, and they are getting into, and medical intervention. Drones are another big field where the technology which we have developed, both in terms of hardware and software. You need mission critical and safety critical software. All these things are now in a big way has gone into unmanned air vehicle program. Okay, it has gone into big. And third area which is going on now, see, you have developed a 14-seater, commuter aircraft, 19-seater. Saras is very much an aircraft which got benefited from the whatever technology we have developed in the light combat aircraft and all that. And we are planning now to make a 90 to 100-seater aircraft. Okay. So with that kind of thing, both manned and unmanned combat aircraft also work is going on. And there are hundreds of engineers who work on an LCA project have joined private industry. One of the things which got benefited is the civil aviation needs that all the software developed by the OEM, original equipment, original aircraft developer, to get it tested by a third party. Now, Indian software companies have become the center for third-party software testing house. There are many industries who are, and I think the seed has been by the people who have worked in LCA, moved there. You could see today the leadership roles in quite a few of these industries, okay? Whether it's IT industry or other avionics industry or many of these industries, they have come there. Third thing we'll see, LCA today is being manufactured, in addition to HL, L&T is making this wings at Coimbatore. Front fuselage is done by Dynamatica Technologies. Center fuselage is done by VEM Technologies. And the rear fuselage is done by, I think, Alpha Technologies and all that kind of thing. So you can see that the knowledge base is getting transferred for manufacturing. And this is going to help us to increase the capability in the country. And I do think the spin-offs are quite a bit. And at least 20 small and medium-scale industries I know who have started exporting their products all over the world. So that is a good thing that happened.
Sure, sir. Thank you, sir. Third question. Dear sir, your views on the use of drones and swarms of drones technology, sir?
I think drone is the future of India, not only in military, but in civil, big civil. I'm looking at drone is a big enabler in precision agriculture. Very big enabler in precision agriculture. In fact, I think more than a year back before this COVID business, I have visited twice or thrice to IIT-Dharwad. Talked to Professor Seshu and the whole team to join hands to make this precision agriculture to happen. Okay, the company what I'm talking about, which is incubated at University of Science, and today they have already done spraying for thousands of acres, and the AI technologies that are coming out, okay. They are the drone, once it does a what you call a survey, and it takes the imagery, and AI you use it to interpret the imagery, and based on that you know the diseases of the crops, and then you do the spraying. End to end, this capability has been developed now. Okay, and that is the benefit. And we have done, say, for half a dozen crops, but India has 50 to 100 types of crops. So the what you call opportunities are extraordinary. Okay, and I think with the new drone policy which India has came out recently, it is a very progressive. If you see the old policy, it was designed to prevent anybody to take off above 10 feet. But the new policy is just wonderful. Very excellent policy, very progressive policy, and they have recently come out with called productivity linked the PLI scheme. That means if you make a drone in India with Indian components and all, you get government support up to 20%. I thought it's a very progressive thing that is happening in the country. We must compliment the government for coming out with such a progressive plan. And there is a UTM, unmanned what you call traffic management. And from January next year onwards, it will become totally, it is now under testing, totally it will become operationalized. And that itself will enable the civil applications of drones by, my understanding is 2 to 3 orders of magnitude. Okay, that is the thing.
Okay. Thank you, sir. Next question we will take, sir. Sir, currently private industries are partnered only for manufacturing already designed systems or for developing very specific few technologies for fighters. But what
they have done a lot of technology work has been done by the what you call private industry. In fact, almost 300 industries have participated in making various development. I'm not talking of manufacturing. Manufacturing is separate. They have worked. A lot of industries, they have done the job, they have done avionics, they have done mechanical systems, they have done hydraulic, they have done fuel systems, so many things they have done, okay? And electrical system, looms, cables, so many connectors, so many things they have done. And not only they have done for us, but now they are using the technology base and production and productivity base to export. Okay, lot of export is going on.
Yes. So second part of the question, what's your take on India reaching a level where multiple private players can be partnered to design large-scale subsystems like in US and European Union, sir?
What I feel now we are looking at it is, a regional transport aircraft, what we are talking now, a 90-seater, we are looking at private players to play a big role. Okay. Fortunately, recently you have seen the government has placed an order for about 56 aircraft of C295 and Tata Advanced Systems Limited. Only 16 will come from outside, 40 they will manufacture. In other words, so this will be the first private industry who will not only manufacture an airframe, but assemble it, test it, and fly it. Okay, for there. So the manufacturing capacity is there. They will be able to build in the private industry. And various, there are some private who are also making small engines, like what do you call, the Pune company, idea of, what do you call, they are doing this work. And I'm looking at in the unmanned vehicle, they will come up. And in the manned, the problem is in aviation, the investments are too high. If you have to make a 90-seater aircraft, minimum $1 billion, minimum $1 billion investment is required. Unfortunately, none of our private industries are willing to invest that kind of money because the return on investment for this thing is not 5 years. They are used to 3 to 5 years. This will be 20 years. So some kind of a hand-holding has to be done by the government. Then what happens? The industry, both public and private, would be able to come together and make it happen. But I'm looking forward to next 10 to 15 years, the private industry will come in a big way, not only in unmanned, but also in manned aircraft.
Sure, sir. Sir, next question. How should the academia ready itself to prepare the next generation of engineers who can sustain these developments and further improve it, sir?
If you look at the history of LCA,
yes,
it is characterized by the intense participation of the what you call academia. I'll give you 1 or 2 examples. You will see. We wanted to use an advanced composite, carbon fiber composites there. Okay, and the whole airframe was made out of composites. But you know, composite is a bad conductor. It's not a good conductor at all. You need technology because the nature will have lightning, all such problems. So there was a need for a technology to what do you call make the carbon components, carbon fiber component compatible with lightning. So lightning protection is required, EMI protection required, and all. The whole facility and the technology of what you call designing the composites has come from Indian Institute of Science. Okay, there was a head-up display that was being developed by one of our lab called CSIO at Chandigarh. Okay, it's a CSR lab. They were very good optical technology, but they didn't have the coating technology. Interestingly, that coating technology came from Indian Institute of Science. Okay, we were trying to develop a simulator for maintenance crew. Always simulators are there for pilots. We felt there is a need for the total technology for the maintenance of what you call aircraft, fighter aircraft like LCA came from IIT Bombay. Okay, Professor Patak and his team, they did the job. And a lot of work in controls, a lot of work in controller development. There are a number of areas. It has come from all the IITs and computational fluid dynamics, computational electromagnetics, and finite element aero servo elasticity. I want to mention to you, this aircraft is an unstable aircraft. So you need the aerodynamics, the structures, and control, the interact. And so that the interaction can be very adverse. So we needed a software. Professor Surnaran from IIT Bombay again, he came for a year, spent 1 year with us. He, along with the team from HAL, NAL, ADA, they worked together, they developed a software. Today, that software is the backbone for control desires. Okay, so enabling technologies, test facilities, all of them, they've done a big job. And the core technologies, I have given you 2 examples, also done a great job. So today, the academia knows where it has to work, how it has to work. And I think the LCA project has given them opportunity, and LCA got benefited by their participation. It's not just 5-10 people. At least about 150 to 200 faculty have participated in this program. Okay, so I think the trend is very clear, and I'm sure in future programs also same thing will continue. Okay, I am sure my successor Subramaniam is here. He has also followed, and his successors, everybody will follow and see to it that more and more academia will participate in that.
Sure.
I see golden opportunity.
Sir, next question is: are there any plans for indigenous development of attack helicopters?
Actually, HL is already doing. HL is the premier house for helicopters. They have done a light helicopter, but now they have developed an attack helicopter. They're on the job. Okay,
Sure.
they are in the business. I think they are the prime agency, and they have the know-how and capability to develop unmanned helicopters. In fact, IIT Kanpur has done a fantastically good job. In fact, they have a startup also. They are going to do a lot of things. But attack helicopter is again a costly game. I don't think a startup or a small industry can do that. HL is very much in the loop.
Sure. So probably one last question, and a very interesting one. It is more about you rather than the LCA Tejas. Probably from our younger audience. How do you remain so joyful and excited about technology?
I thought we are. I think that is what excites us most, and it is the technology which. See, I'm a boy from a small town, from Odisha. Okay, I'm not from a big city or anything like that. What propelled me and many of my colleagues who have come from smaller places is the challenge of technology. And today, the environment to learn is far higher. Okay, the tools available for learning are higher. The only thing I want to tell my young colleagues is learn, continue to learn to learn.
Sure.
I think that is what is required. Okay, learn to work as a team to produce. Okay, and have a T. My suggestion to them is have a T formula. One area you become a guru, expert, and all other areas you must have enough understanding so that you can work as a team and produce. And I'm seeing more and more engineers are coming together along with engineers, professionals, and they are coming out new startups, new things. And I do think it will be a wonderful thing for us to happening in the country. I am seeing a lot of positive things happening in the country.
Great, sir. Thank you, sir. Professor S.S. Murthy has raised a question. Sir,
Yeah.
you can please.
Yes, Professor.
Sir, you may have to unmute, sir.
Yeah. Of course, it was definitely very wonderful lecture and very passionate, and it is very timely. I have a few issues, basically, because I heard your earlier webinars also. One thing is, I feel we should, we should go fully on all electric aircrafts. I think because we cannot delay this, because everybody all over the world are going in a big way on all electric, and we have capabilities in India. We can produce, as you said, typically for your UDAN schemes, even start with a small one, maybe 20-seater, 40-seater, 80, whatever, go there. And we have enough capabilities. All we need is a battery. We can make the inverters, we can make the high-speed motors, and propeller, etc. But I think I have been always propagating the very famous thing for IIT-Dharwad is to take up as an interdisciplinary mission. I call it as a clean energy and green mobility.
I hope the director is listening to you.
Yeah, he is. I know he is listening, but he has his own parallel other commitments.
Yeah. After you complete I would like to respond because this is a subject
because I feel
great interest to me.
After all, I think we can do little hand holding. I think in this region there is a lot of forces or support systems are available from Bangalore, Pune, from Dharwad, Hyderabad, whatever. And I think we can all go together, make it as a national mission project. And I would say green mobility, starting from a two-wheeler up to aircraft. And technologies are almost similar. It's all battery-driven, then motor-driven. It only thing is ultimately whether it goes on the land, etc. That's what matters. I think and we should not delay this project. I feel, I don't know, because I think...
Professor Srinivas Murthy, your points are absolutely correct. And last few months, maybe last 6 months also, I've been deeply looking at electric aircraft. Okay, in month of February, along with the Design Division of Aero Society, NAL, and IIST together, we are conducting a workshop on electric aircraft and technologies. Okay, at NAL, we are already on the job of an electric two-seater. Okay, because Hansa is there, we want to modify Hansa, wet our hands and all. But there are two fundamental differences between a ground vehicle and the airborne vehicles. In the ground vehicle, weight is not that much and volume is not that much of a problem. Okay, you may reduce your speed by 5 kilometers per hour. In case of an aircraft, it won't take off. You have to appreciate that a battery, even a lithium-ion battery, the best quality that is available in the world today, okay, has about the energy. See, if you know 1 kilogram of fuel, okay, aviation fuel is 12,000, okay, 12,000 kilowatts per kilogram. Kilowatts. That is watts per kilogram, not kilowatt. Kilowatts per kilogram. Where this is about 250 or so. Something like 40 times heavier. Okay, that's one thing. 18 times higher volume. 40 to 50 times heavier, 18 times higher volume is very crucial for an aircraft, not so crucial for a land vehicle. Okay, charging and all are problems for a land vehicle. I don't think charging is a problem because we are not going to have millions of places. We have 500,000, 2,000 things we can manage. But the problem is this one. And though motors are not as bad as better batteries, but motor also you need what you call high kilowatt per kilogram. Today we have motors who are about 4 to 5 kilograms, kilowatts per kilogram. You need to come to something like 14 to 15 at least to come to that level. And this, if you are talking about 20-seater and all, we can manage with conventional PMDC motors and all that, synchronous, asynchronous and all that. But when you are now talking about the higher capacity, like a Boeing 737 and all, the motor you need in megawatts, not in kilowatts. Okay, when you go to megawatts, a conventional motor technology is not good enough. You may have to go to what you call high temperature superconducting motors. That is the area where we need to do a lot of work. But even up to 1 megawatt, 1 megawatt, even conventional technology is good enough. So I'm happy if you can tell me which are the companies in the country who are working in batteries, which are the companies who are working in fuel cells, which are the companies who are working in motors and other things, and which are the IITs and other academics which are working in that. If you could do, then we would like all of them to participate. And our aim is to see to it a 2-seater, a 19-seater, and a 90-seater. We must be able to make it in there. 2 and 19-seater we should be able to do in up to 3 to 5 years, but 90-seater may take about 15 years. But I agree with you, we have to put attention to it. Our academia must work, R&D should work, and government must fund in a bigger way so that we will move forward. There is no doubt in mind. See, unlike other countries, India imports 70% of its fuel. So I may as well stop importing that fuel and make the aircraft electric. Okay, but technology is where we are not investing money in technology. The problem in India is we don't invest. That is what we need to do that. Okay, I hope you will help me in getting who are the people who are working in the country in this field. Okay, I would also put 1 or 2 of his people. If they can get interested, that also will be a good thing.
No, I think this has somewhere it has to start. Maybe
we will start. I
can only prepare a sort of a concept.
Make India. I don't want what is happening in world. I'm
saying I have
what is happening in India.
In electric side, I have enough contacts in India.
No, that is the reason.
I spent 1 year at Kirloskar Electric, Bangalore.
That's why
I have been consulting BHEL, several most of the electric companies.
Murthy, your comment is a blessing for us. Okay.
No, we are available. Only thing is,
Available, nahi. You have to work.
yeah. No.
First, you collect the information.
The
Collect
thing
the
is we need-
information. Who is doing what in electrical technology in India? Okay.
Yeah. We will
Good,
provide
sir.
that.
Thank you. Thank you for your comment.
Number two, I think another critical issue I notice is the sort of problem of the youngsters to get into core engineering. I believe that has become, yesterday I was talking to a publisher, for there's a delay in publishing my book. He says today nobody wants to read books in core engineering. Okay, I mean, see, the students are not even interested to read books. Number one, in core engineering more so. Okay, now the problem he gave an example in Kalinga Institute, a well-known institute in Bhubaneswar. They are taking 4,000 students admitted and 3,500 in computer science. Maybe 200 in electronics communication, maybe 50 in electrical engineering, maybe 20 in mechanical engineering. He gave me this sort of number. Even in Bangalore, you look at the premier colleges, institutions, they take 1,000 admission, means 700 or so in computer science. And they say, now the point is, I think this has become very critical. So it would be in the so-called core engineering disciplines or the manufacturing people, industries, they have to go for campus interviews. Okay, it must be proactive, and you must motivate the interest. It is not that students are not interested. Students are somehow are not motivated by money.
Not only motivated, they are also not seeing job opportunities. So if there are job opportunities, people will learn and jump into it. That is what you have to do. We have to create a better industry. But the industry should not be doing only some 50-year-old technology in India. You have to do industry which is based on technology, and both private sector has to do a bigger role in this one. I hope it will happen, but it is essential. Then core engineering will attract the best of the talent. I've seen some of the startups. I was telling you, some of my young colleagues are from IIT Kanpur, IIT Bombay, and all of them they are getting 1/10 the price. 1/10 the salary, but they're joining because they are getting excitement in developing technology. Opportunity should be there, that is the point. You have to create that opportunity. You have to create that opportunity.
And my last point is about the applicability of drones. I think you have clearly said that it will have a major impact in the way the things work. I feel, like a example is for making Bangalore more livable. See, the Bangalore has a 3-4 problem. It is not a livable city as of now. It has very bad roads. Garbage management is terrible. Transport management is horrible. And energy management is nothing to,
COVID became a blessing.
Huh?
COVID became a blessing. Nobody is moving.
Yeah, no, that is true. What I feel is, I feel drones must be immediate. Must be put on a surveillance in Bangalore. Number one is they should every day they should spot the potholes on roads, and it should go directly on the chief minister's table every day. How many potholes in which road? Number two is where are the garbages are dumped? It should also go there. Similarly. I think, even the renewable energy, solar panels and things like that, there is plenty of opportunities for drones to
General Sundaram is hearing you.
Yeah. What I feel is, this is one thing, it must be, because this type of problem, New York or Washington may not have. But it gives a golden opportunity that if you can make...
My friend calls Bangalore is a holy land full of holes.
Okay, I think I spoke a lot. I think I'll stop here. Okay.
Kota, I have a small question. You remember about 7-8 years ago when we gave that future program for DRDO?
Absolutely.
We added a small appendix. Remember, we added as an appendix on cyborgs, flying cyborgs.
Yeah.
They won't require any fuel, but they're still required for the type of activity.
Very much required.
Maybe IIT Dharwad can think about it for their students.
Absolutely.
And,
General Sundaram spent more than 2 decades on those mini vehicles.
That was back in 1998.
I'm happy you made a suggestion. I think IIT Dharwad can look into those kind of things. Okay, this area
1998 we looked at for drones.
needs technology.
It's now more than 20 years.
It doesn't need
The
too
whole
much
world
money,
is
but
talking about
needs
drones.
innovative thinking.
Okay.
Good, sir. I'm very happy because you have worked in this field for ages. Very happy.
IIT Bombay took a very big lead in that.
Very big
you
lead,
know.
very big.
MIT took a lead.
Yeah.
And then, we slipped back. We could think of it again is what my
I
sense.
think, see, we'll not worry about past. We'll worry about present and future. I
Thank
think
you.
Professor Sunil
Yes, sir.
Terlekar has a point.
Dr. Sunil?
Yeah. Actually, I wanted to mention fuel cells, but I think you have already said that.
Okay.
No, but the point is, my worry is the fuel cell work what was going on about 5 years back. I don't see that much even going on now. If you feel there is some work going on, we want to know, because I find for a long endurance vehicle, a combination of a fuel cell and a battery is a better solution than a battery. Okay, because fuel cell will give you small power, for a continuous one. Okay, so that is ideal. But if you can help us to identify who is working on fuel cells, because
Yeah,
I'm
so-
seeing even
No, I'll sometimes sit with you and get more details.
I look forward to look forward. But meanwhile, you can put together, because when I was discussing with people, there used to be a very good research group of DST in IIT Madras, what you call park, that aviation, and that park, it's not aviation, technology park. I understand they wound up.
Oh,
My point is, if such groups are wound up, there are groups. For example, in DRDO, there is a what you call lab which works for fuel cells for submarines. Okay, but you have to now look at who are active groups. How do we bring forward? If Professor Serlekar, if you can, I have asked Srinivas Murthy. Now I'm asking you also. With
sure.
people starting with S, I will ask her.
I'll sit with you once.
It will be good, sir. It will be good.
Sir. Okay, sir. Thank you very much for a very nice discussion and a very nice presentation, sir. We thank you very much for taking us through this journey of LCA program to regional transport aircraft development. Team SAMVAAD would like to thank you for accepting the invitation and delivering the talk, sir. And we would also like to thank the audience for taking their valuable time and attending SAMVAAD. We would like to say that there are updates on SAMVAAD on our IIT Dharwad website, and we request you to please keep regularly checking for the updates. So thank you once again, and good day, sir. Thank you.
Thanks to you all. Thanks for, okay. Thank you, sir. Thank you.
Thank you.